We have a great talk today. I am very excited to announce that Mariya is with us, and she's going to talk about how we can leverage this ML tooling ecosystem, how we can make the best out of it. Because I imagine a lot of you are like me and you've maybe played around with a few tools, but there's so many, and how can you make them work together? What can we do to make them play nice, right? Just a bit of background on Mariya. She comes from a software development background, and she started her career as a Java developer and then switched over, became more and more interested in MLOps and AI for the last couple of years. Right now, it's been a few, I think.
Well, for a little bit of a year, bit that for
Uh-oh. I'm not sure if it's me or if it's you, but I think one of us is breaking up. So
look.
if you, what we can try to do for now is we will turn off video, see if that helps with the bandwidth for you. I know it's not as cool, but yeah, we'll see if that helps. We all like the video. And I'll just finish this intro. We'll see if your connection stabilizes. But Mariya came to AI and ML. I think she said she's been doing it for over a year, over a few years. If anyone else caught it, please correct me. And she's finished a lot of books, read a lot of, or done a lot of courses, finished a lot of books, and wrote a fictional series on AI, which is very cool. Now, she believes that proper tooling and decent development of operation practices is essential success for machine learning. And I think we all can agree with her on that one. That is something that we are here for, right? And if you've been in our Slack, which shameless plug, we have a Slack, and go ahead and get in it if you're not in it. Chris can drop a link to that in the chat. Mariya is super active on there and very helpful. She was the one who had the initiative. She created the initiative to start a questions and answers channel. So if anyone has questions about different things that are coming up when you're in your ML ops lifecycle, she's there to help. There's a few other really smart people that are in there, way smarter than me, as you can imagine. And they are very generous with their information, their knowledge. So if you have any questions about anything MLOps related, get in there, ask questions. I'm sure Mariya will be happy to help you. Now, let's see. Here is the $1 million question. Has your internet stabilized, Mariya?
Well, do you hear me?
Yes, that is a first success. We do hear you.
First success, yeah. Because I heard all your last talk last 0 minutes, so probably it's more or less stable now.
Okay,
cool.
It's
not only the problem with internet and overloaded mobile systems as themselves, but also it is a problem of a lot of people coming to the countryside in the middle of summer.
Totally.
And it's yeah, and it's also it's raining.
Oh,
which
that
is
helps.
Another kind of trouble. Yes.
Yeah.
So,
well, maybe can we try with the video on, and if it gets too crazy, we'll shut it off again?
Yeah, let's do.
Right,
I can.
Let's do it. Let's see if it works.
Oh, I can start it myself. Wow. So please do.
Wait, oh, I need to turn your video on.
Yes. Yeah, because the host stopped it. I can't turn it on.
No. Let's see if we can figure this out. There we go.
I think I turned it off, D, so I got it back on.
All right. we got it. This is,
Okay.
thank you all for sitting with us in these hiccups. I appreciate it. Now, let's get into it. You wanted to talk to us today about leveraging the ML tooling ecosystem. What exactly, which tools are you going to talk about? What do you want to talk about? I know you have some slides prepared. Do you want to just jump into the slides?
Yeah, well, let me start with a small intro about it, and then I will jump to the slides. So, well, I thought about this talk, and when I was preparing for it, I thought, okay, we have a lot of experience in ML operations, and I will show you an ideal project with ideal pipelines which we use for our clients. And then I started preparing the deck and diving into the details, because actually I'm head of product. I know what's going on, but I'm not the person who writes these pipelines and all these integrations. So I started diving into the details. I also watched several talks from previous meetups, and I suddenly realized that this is not ideal. So I will show you what we have now, and I will describe briefly which directions of improvement we see and where we're going with it. So anyway, I want to show you how we built a complex system, integrating a lot of various tools into one system on the base of some generic core. And let me jump to my slides.
Yeah, and
Just a
as you're
second.
doing that, I think what you had told me, and correct me if I'm wrong, I'm sure you're going to get into it. The tools that you are using are, you're using a bit of DVC, Git, Seldon. You're also using Airflow. Is that correct? And
Yes.
then Grafana.
Yep.
And I think there's a few more in there that I may have forgotten, but that is the whole thing. So we can't, oh, there we go. Now we see your screen. It's a white.
I'm trying to run present, but it's, oh, does it
There
work?
it is.
Awesome.
Cool.
So you see, I like the colors which you used. We have the same.
They match
We have
perfectly.
this. Oh yeah. So yeah, we well, I know that I represent a vendor here, so I need to be very cautious. But still, I will try to tell a little bit about our product without directly advertising it. And let me start. Well, first with a task which we are going to solve in this particular example, which I wanted to show. So we are solving a very applied problem. One of our departments is doing ML services for different countries around the world. And we are doing a very applied problem. We are solving a very, very applied problem. We need to develop and deploy an object recognition system for retail. So you see to the right, the image, what our clients want to see is have this all stuff to be found and recognized. So the problem here is mostly in the production rather than in the machine learning part. So new data arrives daily. We need to retrain the model very often as the new data arrives, and we need to redeploy these new models as soon as we get more information. Well, the nature of the task is that the people which want to have the system, they go around different shops, make a lot of new photos, you get new kinds of objects, thus you have to retrain. So yeah, that's the main problem. So to solve it, we need some core. On top of this core, we build all the integrations. And as a core, we have our own product, which is Neu.ro platform. The main part of it is resource orchestration. It's a platform which is built on top of Kubernetes. It's infrastructure agnostic. You can run it in cloud, in premise, in hybrid installations of private and public clouds. It has some additional perks over Kubernetes like SSO, single sign-on, role-based access control. It has ingress out of the box so that you don't have to set it up. And it has a unified, simple interface and allows migrating between various infrastructure backends very smoothly. So like you can, for example, if you are a startup which gets a lot of credits from Google, for example, you can install Neu.ro there, then you will run out of these credits and install Neu.ro on your AWS installation with another ton of credits and migrate very smoothly without changing interface or any habits or something. So that's the point of this thing. It hides the infrastructure from you and gives you a bunch of abstractions, which can be used to build higher levels of the product. So the concepts actually are clusters, storage, Docker images, and jobs. Four main concepts we work with. Clusters, aggregation of your compute, GPU, CPU, storage, and Docker registry, private registry on the platform. Storage is an abstraction over network storage or object storage or distributed file system if we speak about on-premise installations. It's just an abstraction that gives you like another view of your file management. Like you do not have to think about particular machine or particular drive where your data is or your files are. You just have a unified interface to access them as parts of your personal namespace or the namespace of your team. Like you don't think about infrastructure, you just deal with storage, which does something behind the scene, but you don't have to think about it. Everything which happens on the platform happens inside Docker containers, and we can use images from public registries as well as private registry on the platform. And an execution unit is called job. So in the example to the right, you see how we run a job, which has a name, train. Give me a second, which has a name, train, which actually runs project train by a Python script. It is executed on GPU small preset, which is a part of cluster. So when you run a job, you do not think again about the particular machine. You just need to think in terms of what kind of resources I need to this unit to execute. So you run it on GPU small preset, which is in clouds usually K80 NVIDIA Tesla GPU. You run it with some parts of some parts of the storage mounted, and on some public or private image, which is in this case your machine base. So that's actually, these are four main concepts. If you want to, you can build actually whatever you want on top of these concepts. If you have enough drive and energy and time and desire to do that, you can build anything. But the main question is that enough to solve our task? Of course it's not, because it's a generic platform which doesn't refer to machine learning or machine learning operations, to be honest. It's just a resource orchestrator in this part of it. So what you need tools. And here is an interesting question, which I guess any company like ours has. A customer would like normally to see all the tools in one place, like have a unified interface for everything they need for machine learning or for machine learning operations. like data registry with the same interface, which is model registry with the same interface as pipelines or something else, whatever. They do not want to have a bunch of different tools and to set them up manually. But at the same time, you need a tremendous amount of resources to create a product which does everything. And probably you won't be able to do that after all, because the tools in this field are changing so fast. And you may think about integrating or writing your own engine for hyperparameter tuning, and then someone like Facebook releases a new cool library which does the same but 10 times better. So you will already be behind. So we realized that we clearly are not capable of doing everything by ourselves. That's why we went into the direction of integrations. And then I want to show you some examples of tools, how we integrate them for which purpose. So like if we split, I'm sorry, if you split the ML project process into two major stages, like development and production. In development, we use this number of tools. We use Cookiecutter for scaffolding, and actually it is hidden from the customer. We have a Cookiecutter template, which is public, but yet we have a command in our CLI which just runs this Cookiecutter template. If someone is unfamiliar with Cookiecutter, it's a Python tool which allows you to define the structure of files and directories which you would like to use for a new project. Like you run Cookiecutter from this GitHub URL, and you get a structure of a new project with some variables replaced with the ones which you provide to Cookiecutter. So it runs, asks you a bunch of questions, and creates a template for you. It's extremely popular in Python. It's used for Django very actively, and it's also used in data science. There is a very popular data science. I don't remember exactly how it's called, but you can easily find Cookiecutter data science template. And we created a separate one for us, which actually integrates all these all the tools for the development, so that you can run them in a short command from a makefile. We run Jupyter Notebooks for experimentation. We run Tensorboard for experiment tracking. PyCharm Professional is normally used by our developers for code editing and debugging. And for the PyCharm Professional, which is, I think, only not open source tool in the list I will show you, you need to have a license first, and then you need to have a small setup. But it's also very useful. And we use Git for code management because like you get this template from Git and you are expected to push it. And there's a git ignore file and a specific structure. So we imply that our customers gonna use Git. And for data and model management in development stage, we use simply our storage. In this part, neither data nor models are versioned, because we spoke to a lot of people who run many experiments in development stage, like the place when you just try different models and see how it goes. They are rather interested in running a Jupyter notebook or running training with one command rather than dealing with data versioning and model versioning, because actually you are not really interested in all this production grade stuff until you get a first decent model. So in this particular development template, which is scaffolded by Cookiecutter, we just use our storage as a backend, and that's it. So project template commands just to give you some understanding, as I said, you run init, you answer a couple of questions from Cookiecutter, and you get a file structure and make file which contains very short commands to run on Neu.ro. As you saw, the commands are actually pretty long. You saw the example of the previous slides. But make file just brings together all the variables and all the volumes to mount and hides all these details from you. So that's actually interesting, but not really, because if you want to develop, you still can simply go for collab, or you can go for, I don't know, uploading your code to a remote server if you have access to. It's still, it requires some aid. We may make it more convenient, but it's not the main problem in the world of machine learning today. And here, where the problems start, real problems, when you want to make it into production. And for the production, we decided to integrate with cool and proven tools from open source world. We write pipelines.
Do you mind if I jump in real fast? I was just going to ask, you mentioned
yes, please.
Here the problem starts when you want to make it into production. Why is that?
Because in production, you have to bother about so many things. You have to bother about the versions of your data. You have to bother about the stability of the deployment. Actually, you have to deploy this stuff somehow, somewhere. You have to balance the load. You have to monitor if the model behaves well after some time, after a lot of new data arrived. It's just too many things to think about. When you develop, you're not concerned about the quality of the code. You're not really concerned about whether it will, I don't know. I think that it's when you just develop the model, you mostly get fun. But when you come to production, you have to make it profitable for your business. And here's where fun stops. You have to make it work, automated, stable as a clock. And here you really need a lot of additional tools.
Great point.
So we there are actually two slides with production tools. This slide is devoted to the ones which are platform level, like not even small tools that you can run on the platform, but entire huge whatever that you have to run along the platform. We use Airflow for pipelining. And technically, there is a separate installation which runs on the same Kubernetes cluster and knows something about the storage, which has some specific Kubernetes tokens, whatever. I'm not sure. That's more of the question to our MLOps engineers. So it has to run nearby the platform. We use Seldon for deployment. It's also a separate installation, and Seldon solves a whole bunch of problems for us related to not only providing the API. In the development mode, we can host a job on a platform which provides an API using, for example, Flask server. But when it comes to production deployment, you need to balance load, you need to capture a bunch of metrics, you need to monitor all this stuff. And Seldon does exactly that for us. Seldon does even more. We just, to be honest, don't use all its functionalities. We're just exploring and we'll use more, I guess, pretty soon, like A/B testing of models and that kind of stuff. And we use Grafana for monitoring, mostly because it comes together with Seldon. They are already integrated fine. So you install Grafana, Seldon writes logs to Prometheus, Grafana reads these logs, and that goes smoothly. And I can show you how the docs, the pipelines for this particular use case look. We have three main pipelines. One for data preprocessing, when you have a new bunch of data, new portion, and you want to merge it with existing data set and make a split to train, validation, and test. As usually, like just mix and make a new data set. So this pipeline accepts a new data portion and a base data set to use and creates a new data set. Another pipeline takes a data set and the model code and a base model. In our particular case, we retrain the model. So we use some model to build another model on top of it. So it takes a model version, a data version, a code version, and creates a new model and puts it into the registry. And just for you to understand, the most of these rectangles, these steps in Airflow, they happen right on the platform. So that's a level of integration which we have with Airflow. We have our custom plugin which knows how to work with the platform, despite the fact that Airflow stands beside it, besides the Neu.ro installation. Airflow knows how to talk with the platform and how to run jobs on it and how to read storage and so on and so forth. I mean, we could use Bash and CLI, but this kind of integration is more powerful because we can do more cool stuff there. So these rectangles, I guess all of them which are white, yeah, I guess that's white rectangles. Airflow has some weird scheme of coloring. That's the only problem which I have personally with Airflow. I don't remember their color scheme, but I guess that white rectangles are on the platform. So training job happens on the platform, and all the validations before training, after training, committing the model, everything happens on the platform. And then the last pipeline is to get a model and to deploy it to Inference. And you can see that these docs are pretty large, not only because there are a lot of steps involved, but also, I mean, a lot of logical steps involved, but also because there are a lot of checks, like you run a doc, but you have to provide some arguments, and if you forget them, or if these arguments are invalid, then doc should fail and should tell you precisely what happens. So if you run this doc and forgets to give a model, then it will fail, and you will clearly see that it fails because you forget to provide a model. Like the most simple example here. And like you get a model, you validate it, you run inference, you run monitoring, you can open up the interface of each of these tools right from the doc. So for the production, it becomes the major source of information. And also, it's worth mentioning that we use Git for keeping the docs themselves. So Airflow docs are stored in a separate Git repo, and every minute, if I'm not mistaken, Airflow installation pulls the docs and redeploys them if it's needed. So like 3 main docs and a couple of other ones which open up Tensorboard and a couple of other tools on the platform again.
I see a question here in the chat from Ivan. He's asking how many models you have in production so far.
Well, in this particular example one, so we speak about a bunch of docs for one model which is being updated.
Perfect.
But actually, each doc, each task requires another bunch of docs and another resources. And in this particular case, we run all this stuff on a dedicated cluster, which is used by our internal team. And in this cluster right now, we run only this model. Our approach is basically to run a model or a bunch of similar models per cluster. Making a cluster in Neu.ro is pretty simple, so we opt for splitting resources for models. It's easy to monitor and to understand what happens with them. So these are three major pipelines, and this is an example of Grafana monitoring. You may see that maybe these graphs are not really interesting because in this particular case, our MLOps engineers run all these pipelines on a copy of the project, not the customer project, but on customer data. But they used Coco dataset and some basic model just to demonstrate the stuff. So not much data can be seen on this Grafana screenshot. Also, that's the first part. That's when you need huge tools which run together with the platform and have to somehow communicate with it. Another bunch of tools is the ones which you use for management of various pieces. And the first one and the most complex one, I guess, is data management, for which we use DVC. And we use it together with our storage. And what actually happens? We keep DVC files. You know that DVC the normal workflow with DVC is when you have Git. But in our case, we decided to start with a version without Git. So when you commit something to DVC, you get a bunch of DVC files, caches, and we keep these files on the platform storage. And we have like a bunch of directories, one per version for dataset version, and we can always grab these DVC files and copy them to a predefined location and restore the dataset. It's actually pretty similar to Git, but instead of having version control stuff, you have a bunch of folders, which actually works because these files are very small and this is not a problem to keep them alongside the data. So the pipelines which do the pre-processing, they pull data according to these DVC files. They do whatever they want to do with it, and the data is the actual data at this point is also kept on the storage. And the volumes with this data are mounted to the jobs. It works surprisingly fast, I must say, because this is high throughput network storage, which we normally use, and it gives you high speed, and it's not that huge problem that we expected it to be. I mean, when you have some additional storage, some like network storage, we would expect that it be way too slow to make any data modifications. But in our case, it turned out to be just fine. So we do all the stuff with data on storage, and we update the data sets and copy the DVC files to a new location. So that's our current workflow with it. For the code management, again, right now we use storage itself. We don't use Git. And the code is copied to storage during the development stage. The reason for that at least at the current point, is that the code changes very seldom. At this point of the development, the data changes, but the code hardly changes at all. So there is some model which is being retrained. I mean, so the code of some model which is being retrained and doesn't need a lot of attention from ML engineers. For the model management, we use Tensorboard. I will show you a screenshot in a moment. And all meta information is also kept on storage. Under meta, I mean stuff like which model, which base model, and which dataset were used to create this particular model, so that you can trace back how this model was created and reproduce it. And environment management is done through the platform registry, and pre-built images are copied. Again, the images do not change very often, so we just create them during the development stage and keep them there. So every time you need to change environment, I mean Docker images, containers, and code, you just need to copy it from your local machine to the platform storage. That's how it works now. So the data registry in this toy example, which our ML ops engineers prepared for me for this presentation, looks like this. You can see the bunch of folders in FileBrowser. FileBrowser is another tool that we use inside the platform. It's a very handy way to monitor the files on your network storage on NFS. So you can see that there are several versions of data, and to create these data versions, we have a special script which looks through the content and figures out the number of the next version of the data. So that I mean, this is important because we started with using the current time, the timestamp. But when you have a timestamp, it's really hard to compare something. And when you have D4, D5, D whatever, it becomes so much easier. So we decided that it's worth writing a small script which gonna help us to monitor this stuff. And for model registry, right now we use Tensorboard, which runs on top of the folder where all the results, all the logs are kept. So you can always compare different versions of models. Like in this particular example, I have 3, M0, M1, M2, and I can see the metrics, I can see the number of epoch and loss and all that kind of stuff. So that's definitely not the end of it, because we understand that there are a lot of issues in this particular pipeline and this solution. And the most important thing that we want to do, and we will do pretty soon, we want to make a proper CI/CD. Someone recently shared a nice story in the chat in Slack of the community, which showed 3 types of MLOps maturity for a team. When you do everything manually, when you have some pipelines, but you still run them manually, and when you have CI/CD. Like in this particular case, which I show you, we run pipelines manually. And what we want to do, we want to have a CI/CD, of course. So we want to use Git, and we want to have proper automated behavior, like new data comes, great, let's retrain, and no, new data chunk comes, let's make a new data set. New data set appears in Git through DVC, let's retrain the model and keep it into the registry. New model code appears, again, let's retrain and keep it into the registry. And new model in the registry appears, let's deploy in dev environment. Production environment is still a question, and we think that it should be done only manually. But you have to understand what you're doing when you're trying to deploy a production model. But for this development stuff, we actually have to implement this continuous integration and continuous deployment stuff. And also, there are some improvements which we can envision right now, and I think that there will be more that we will see later. Like we could build Docker images right on the platform instead of copying them, because well, it's somewhat makes it harder to reproduce, because you may lose the image in the private registry after a while. You may delete it. But if you build an image from a Docker file every time you want to run a pipeline, then you're just fine. You can reproduce in exactly the same environment, which you had 2 months ago or 7 months ago, whatever. And we are not really satisfied with our model registry solution. We are looking into something like MLflow, and we'll probably use it, or maybe something else. There is plenty of model registry tools on the market right now, so we're just evaluating and looking for a best one for this particular case. So that's basically it, which I wanted to show you today.
Thank you so much for that. I have a few questions. I'm sure other people have some questions too.
Sure.
And I really think it's fascinating how you've been able to build one level up and take all of these tools and put them together so that they work seamlessly and people don't have to think about, you know, Frankensteining everything together.
Mm-hmm.
So my question comes in, how long did it take you to put this whole pipeline together and create this whole product? Because I know there's a lot of people out there that are going through the whole build versus buy question. And when they think about the build, I'm sure it would look, or some people have thought about this exact solution, right? Like, oh, well, maybe I could piece together DVC and put some Seldon, and then I monitor with Grafana. But I'm wondering, how long have you been doing it? What were some mistakes that you learned along the way?
Well, I have to. I'm trying to remember actually. I remember that initially when we wanted to make this particular pipeline, it was like, okay, we know a lot about these tools. Let's make a pipeline for this task. Are 2 weeks enough? Yeah, fair enough. Let's do it. It was, I guess, 4 months ago or something when we started doing it. Actually, the sad thing about MLOps is that it takes so much time to set the stuff up, really a lot of time. And we had to experiment, we had to think about stitching all this stuff together, and think about making it useful, because like one thing is what our MLOps engineers want to see. Another thing is what clients want to see, because they're going to use this pipeline in reality, and we need to provide some additional stuff for them, which is not there yet. Like, they clearly do not want to upload a data chunk to the storage and then run a pipeline manually. We need to prepare some cool web form for them to upload and do everything automatically, you know. And another thing, what ML engineers, which create the model itself, want to see. So we are trying to collect all these opinions and improve. And I think that it's gonna take another couple of months at the very least to make it something which I will probably finally call ideal.
And what do you think was some of the stuff that held you up, and because you budgeted for 2 weeks, but then it's taken 4 months or so? What was it that came up that you didn't foresee?
Well, it took a lot of time to understand how data versioning works, because it was not really clear from the first view. Another serious issue was how to save information for being able to reproduce any experiment, because you need to track the exact versions of everything: code, data, model itself, environments, and stuff, to be able to reproduce it. And we thought for a while how to do it correctly. So we tried a couple of different ways. And this version management stuff also took some time. Like when you start with timestamps, it looks so obvious, but as long as the amount of versions grows, you suddenly understand that you can't deal with it, because you can't read all this stuff through. It's just not human friendly.
Yeah.
So yeah, and maybe some other things. To be honest, it's I'm speaking about what I participated in, but there is also stuff from infrastructure side, like how to install Seldon properly, how to make Seldon work with our storage, how to make Airflow, and how to install Airflow, provide correct level of permissions, and make it I don't know what exactly was the problem. I don't remember, but there were some installation issues, quite a lot of them. So that was another team who was working on that, but still, it took a lot of time.
Yeah, I believe it. And that's something that I know it seems trivial when you're looking at it. You go, yeah, we just piece a few open source tools together, and in 2 weeks we'll have it working. That'll be fine. But
Yeah,
when you
that's like
actually,
we already have them. What's the problem? We can
yeah,
do, like, we use Seldon, use DVC, use MLflow. Of course.
yeah, it should be easy, but it's never that easy, right? So
Absolutely not. Absolutely not. And it's not that I would assume that this is our team's problem. Like, maybe we are stupid, we can't deal with it. But actually, we talk with a lot of other teams, and most of them need several months, up to half a year, to create a proper pipeline in different tools. Like, people use Kubeflow, people use other stuff. It's just hard. It's just as it is for now, for
yeah.
today.
Yeah, and is there any specific reason that you feel it's so hard? Is it because it's not mature, the tools aren't as mature, or is there something else that you think? Is it because just machine learning is so difficult and there's so many pieces involved in it? What are your thoughts around that?
I think that the main problem is in the domain, is in machine learning, because in traditional DevOps, you just, I know that it sounds would sound strange 20 years ago, but actually you just need to deploy the code. And here you need to, like, you need to train a model. No, you need to keep your data somewhere and somehow. You need to update your data sets. You need to train your model. You need to wrap this model into API. You need to host this API. You need to balance the loads and monitor the health of the model, which I don't think that DevOps ever had this problem, that your API may break, not break, but become worse because over the time it's a specificity of machine learning. So it's just harder. It just involves way more pieces. And additionally, you may have expensive GPU resources for all this stuff, and you need to somehow optimize the usage of GPU resources. Otherwise, you will just get very, very huge bills for your infrastructure. So it's just way too many pieces and way too many issues.
Yeah, and as you say that, the expensive GPU, have you thought about for the product? Because I know this is something that we were looking at Dot Science, being able to monitor like which models are using the most resources, um, and who's working on each model, and being able to like graph that out and say, okay, this model is, is it really effective because it's taken up this much?
Well, we can do something like that. We can build reports for the development stage because we can understand which project and which people spent the most of GPU resources for training. For deployment part, actually, we didn't dive into that yet, but thank you, Demetrius. That's a good point. We'll consider that.
No problem. I've got plenty other ideas if you want to talk to me later.
Oh yeah, please do.
Perfect. Well, does anyone else have any other questions? I'm about out. I'll let a little space for someone if they want to ask anything. And if not, we will go ahead, and I think we're going to call it good there. I want to just reiterate, big thank you. It looks like our internet worked and
Oh yeah, it
we
did.
had success. And if anyone is
Oh,
not
Demetrius.
Oh yeah, go ahead.
Demetrius, sorry, I just realized that I didn't answer the question about dependencies. I
Oh
have to.
yeah, that's what I was here for.
Actually, I wanted to tell about two techniques which we use to deal with dependencies held in Python in particular. Like two things are the first one is that we run everything in Docker. So in the case when you have, I don't know, some model which requires CUDA 9, and another model which requires CUDA 11, and another model which requires I don't know what else, Docker just saves your life. And we have seen such kind of pipelines, and we know that it helps. So Docker is a way to go to separate the environment for different steps of the pipeline, the development process. And another thing is that you still need to keep a lot of dependencies for the tools, for the frameworks, first of all, inside one environment. And in this case, for the development purposes, we use exact versions. So we keep all the versions with equals in requirements.txt. And we use Tensorboard to update them, because without Tensorboard, you will hardly be able to update this requirements.txt file as soon as you create it. But if you have it, at least you can always grab all the dependencies of the packages which you installed and create a requirements.txt file with everything you have in this particular environment with exact versions. And at least be sure that this stuff works and won't break tomorrow because a new package arrived. So we use this, and Tensorboard is an essential tool for that, for updating this stuff. But you update it when you want to do that, not when the libraries maintainer want to do that. So like Tensorboard plus Docker, we are fine, more or less.
Thank you so much. That was my burning question. And I am happy to hear about that. I hadn't known about it. It's Tensorboards, is what you said?
Tensorboard is a GitHub tool, actually, which monitors your dependencies if they are updated, and it automatically creates PRs with an update for the package and for the related packages for its dependencies.
Ooh, that's
so you can always first be sure that your tests run, because it creates a PR and your tests run on top of that. And you can check it with your eyes, with your hands, and only when you merge the PR, then you are 100% sure that you did it.
Nice.
It's really much.
Perfect. Well, right on time. I think that's all we got for today. Thank you very much, Mariya. And for anybody that is not in our Slack, go ahead and jump in there. Mariya is on there. She's very active, helping us all learn more. If you have any questions about anything MLOps in general, you can drop them into the MLOps questions and answers Slack channel. And otherwise, we will see you out there. Go ahead and yeah, big round of applause for you, Mariya. I appreciate you coming on here and joining us today. We will see you next week with a bit more of a deep dive into model monitoring. We're going to be with Arpana, and she's going to talk to us about how she does model monitoring. I know we did it last week, and we're going to do it again next week. So it's a big theme these days. So,
Hot topic.
yeah, it's a very hot topic, and I think it's something that people really enjoy learning about. So that's it. Take it easy, everybody. Have a great night or day or wherever you are. Enjoy. We'll see you later.
Thank you. Bye.
Bye.